In this presentation, I would like to share some thoughts about the way we now develop code based on documentation, based on an experience with Nilearn. So I will first start by explaining what documentation-driven development means and how we make good documentations. And then I will go to more details about Nilearn documentation proper. I will finish by an example. So as Julia just said, when you have, you typically think of software development as writing code, writing new functions, writing new classes, and then providing documentation examples and tests and all that. And actually, when the code is done, only half of the work has been done because you've got all the remainder to be done. And certainly you won't be able to enter any code in Nilearn if you don't provide together with it some good documentation example and test. But I think in this talk, I would like to go a bit further, and we have realized year after year how important this documentation example and tests were. For instance, if you take the examples, usually you think examples as a way to showcase the code, but actually if you think of it, an example can tell you how the code should be designed. Examples will also be important to feed the documentation. Documentation should be based on examples. Sometimes you don't know how to design a good test for the code, and this will be discussed later on today. But certainly there are some technical tests, which is just how does the code reply when you do when some arguments are wrong, etc. But I think that the core test should be able to take inspiration from the examples. Test should test how the examples, how the code should be used, so how the examples work. So examples can also inspire test writing. And so in this presentation today, I will be focusing on the joint relationship between documentation and examples as a way to improve the library. So, well, documentation is essential, and clearly this is not negotiable, I would say, because if you think of yourself as a user, for a user, if a feature is not documented, then it doesn't exist, and if a feature is documented incorrectly, then it's broken. So certainly we have to think to have a good documentation which is updated all the time, so that the user experience is okay. And that's why we propose this way of document, program, test, and then repeat the loop. Documentation also makes the library easier to learn and adopt, and for sure. And but also in terms of community building, it makes your colleagues better contributors to the library. It lowers the support, the burden of the support, and it makes your development easier and faster because you know where you're going to. When you have examples, you know what you need and you know how to design it. Documentation, I think, and this is one is really important for me because we're all here for science. We're not here for software development first. At the end, we want to do science, but good examples exactly express how you want to do science, because your example is a simplified case of the science you want to produce. So documentation represents an attitude to have scientific challenges. And it's kind of contract to the community. Oh, this is where we want to go to. This is the kind of tool we want to be able to use and to develop. It's also a commitment to standards of communication. And this is an activity, not just a content. Right, writing documentation is not easy, but still, sometimes for new contributors, documenting a feature is still easier than writing new code. when I have a new library that I don't know well, that is hard to use, sometimes just trying to write documentation for it, understanding what is done on the argument, what is returned, is quite essential. Documentation is always welcome. If you come to Nilearn and say, "Oh, we'd like to contribute documentation," we'll always be happy to collaborate. And of course, it raises your understanding of the library. To understand something, sometimes documenting is a way to, in the process of understanding. Okay, so this being said, documentation-driven development is a way to start the development process by documentation. So what should the function text be? What should it? So in this way, you first think what the code should be, rather than what it does currently, how usable it is now. Documentation-driven development provides a high-level overview of the work. It makes communication easier because you know the block that you want to do. You don't know, it's not implemented yet, but you have a kind of contract of what you want to go towards. So it gives you also a metric of success to drive you to develop the documentation, the code. And also it binds programming efforts into a coherent narrative, because you have the whole story in mind, and you know that the piece of code will integrate in the whole story. So you're not lost primarily in the development details and technicalities, but you get the big picture. So all these arguments I'm making are also developed in the YouTube video, for which I provide a link below. So if you Google documentation-driven development, you will find it. Now, in my experience, one thing is to avoid YAGNIs. So YAGNIs, you aren't going to need it. So it's all these features that come and that are sophisticated and sometimes too sophisticated. And at the end, they make your life more difficult as a developer, as a maintainer of the library in particular. And so I think it's like feature creep. Julia also talked about that. So here I copy pasted an email, maybe from one of you. I don't know, and that's fine. The question in this email, it's just suggesting like to add a new feature, which is great because it has been promoted in a publication. But the problem is that if we accept all these contributions, then we will have too many. It will be impossible to maintain. And I would say a word here about the neuroimaging community. There is a huge creativity on methods to solve problems, which is great on one hand. But on the other hand, it's a bit dangerous because then we don't. We have so many complex data sets that, and then on top of it, lots of different statistical methods to analyze them. At the end, it creates huge degrees of freedom for the analysis part, and it makes our analysis quite unreliable. And so this, at the end, this leads to a loss of confidence of what people do in the community because, well, they kind of extracted some features from the data, but it's so easy to extract features that at the end, you don't know what is real in your data. And so what I'm saying here is that the neuroimaging community is a bit susceptible to these YAGNIs, okay? And then, of course, there is all the code behind. Some ideas may be good, but maybe not in your library. So a good way to think of it and to make sure we're not wasting our time and our resources is to think in terms of examples and documentation. How this new feature will be used? Can I provide a compelling example of its usefulness given the data sets that are available in for instance, with Nilearn? Can I show that this new way of measuring, say, functional connectivity will bring something on the data that we already have. So think with an example first, and then you can see, does this new matrix, this new statistic really provide something useful? You can also think in terms of how should the API look like? Is it compatible with what we already have? And then come more technical aspects like the amount of code that is added. Is it Python code? Because in Nilearn, we take Python-only contributions. Is it cited? So for instance, for scikit-learn, they accept only work with 200 citations. So it's a hard threshold. And in the same spirit, keep it smart and simple. So the idea is that writing the examples or documentation first pushes you towards simplicity, which is always good. It also pushes you toward the consistent API in the way of naming the arguments or keeping the order of arguments, and it makes it easier to convince other contributors or reviewers. Okay. To conclude this first part, I would like to provide some useful references for documentation. I think that NumPy is the mother of all scientific Python projects, or many of them. And so it's always a reference to see in terms of organization of the documentation. Also, we have some common efforts with scikit-learn, and so we have decided to rely on the core API choices of scikit-learn, and on we target the high quality of the documentation of scikit-learn. Then the next library that you need to be aware of is Sphinx, that generates the documentation given the RST, the REST files that are provided in the documentation folder. I will get back to that later. And maybe more importantly, or more simply, simply take a look at the guidelines of Nilearn. So we provide online some guidelines for developments of documentation and of the library. Maybe here I switch to the second part of the talk. Are there some questions that I should be aware of? Okay, let me go on then. So let's talk a bit more about Nilearn documentation proper. So first, the API, narrative and examples, and our documentation is generated. Actually, sorry, I changed my mind and I decided to start with the example gallery. Why? Because when I want to use a feature of Nilearn, I always get back to the examples, because examples already show you how to use the code in a certain situation. And to me, that's really a guiding principle. I just copy-paste the snippet of code I need, and I adapt it to my current needs. So this being said, for this to work, you need first the example naming to be clear enough so that you can easily guess what the example is doing from the very short description that is provided. So the association of the thumbnail and the title should provide you a clear indication of what the example does. Second, the example gallery has to be rich, but not too much. Not too much, not to lose the reader, or also not to take too much time to generate, because the examples have to be generated by continuous integration so that we make sure that everything is working at all time, so it cannot be too heavy. And they have different levels of abstraction or generality. For instance, you've got some examples very specific to brain imaging, like showing probabilistic atlases. Some of them much more generic, like plotting color maps from Matplotlib in Nilearn, or like that one, illustrating a technical point, how we sample volume data to the cortical surface. Okay, Here I just took a glimpse into a very short example that just takes an input image and negates it, computes the minus this image and just plots it. So that's very simple, but so you can see the notebook-like sectioning provided with these lines in the example. There is little code. You don't want to lose people in reading code. And there are plots that people can very quickly see what's going on and what the example does. And when it's generated, this is what the example looks like. So once again, very little code. You can see the block in a notebook style way, and with documentation inserted to make everything clear. Now, regarding the API documentation, so these are the doc strings of the modules and the functions in Nilearn. For instance, if you look here, I took a small snippet from the generated documentation, which is online. And you can see how the documentation is structured. So for each function, it will provide a description of the input argument here, surf mesh. So stating what it is, what it means, the semantics of these arguments, and also the return arguments of the functions. Here, this function actually loads a mesh file and generates and returns some arrays that describes the mesh. And one choice that we have made was not to create yet another mesh structure, but simply represent this with two arrays, NumPy arrays, one for coordinates, the coordinates of the vertices, and one for the faces or the triangles that make the mesh. And this reliance on simple structures is a feature to make the library very easy to understand. Importantly, you want to relate this load surf mesh function to some examples to see how it is used, how it can be used. So that's very important. And another feature of documentation is that it's always to orient the user with a table of content and the previous and next topics. So again, when you look at how the API documentation is written, it states briefly what the function does. It provides a concise description of the parameters and the returned argument. Sometimes we also have a doc test that shows you directly how to use this function. For instance, this one, normalized matrix on axis, could be a bit abstract. So instead, to make its understanding easier, you can simply show what it does on a given array. And then there is another part of the documentation, which is a narrative documentation, which is called user guide, if you look at the Nilearn documentation. And it's really, it tells you something. It tells you a story. It tells you what the library does for you. So it's focused on neuroimaging concepts, not on Python technicalities. And the idea is to make it pleasant to read with the alternance of code and of explanations and small snippets of code and some figures so that the reader can always understand easily what's going on. It's important. It has to be thought of as something to educate people to use Nilearn neuroimaging concepts, to get acquainted with neuroimaging concepts. So if you look now how these kind of things are generated, so it's done in RST. So these very light files that can in which you can have the syntax encoded with the symbols, like here to make a section title, or to make references to other parts of the documentation, and then to insert images, create a table with images and explanations related to the images. So this is a very raw code that generates a piece of documentation. Actually, when your browser sees this RST code, it can immediately interpret it and creates the table and all the structure. It tells you, it provides you also all the links, etc. And then when you compile the documentation and look at this piece of documentation as a finalized documentation, it will look like that. You have a section which provides a small explanation, and then a table with some snippet of images and an explanation each time. So you try to make the explanation as visual as possible. You avoid lengthy explanations, rather illustrate a simple feature with an example each time, so that it remains minimal, so that you can easily grasp that. Now, the way to generate the doc, there are two main ways. You can do it locally on your machine while you are contributing. So in the Nilearn/doc directory, just type make HTML. It will generate all the documentation for the library as an HTML documents. It's very time consuming. So you can also have the fast version, make HTML-noplot, which will do the same, but without executing the examples. And the other way is that documentation is generated by CircleCI when there is a pull request. So there are a certain number of steps which are launched automatically when a pull request is issued. And among them, the CircleCI will generate the documentation. And it's a kind of test also to see if everything works. Now, if you click on the CircleCI thing and go to see the documentation generated on CircleCI, in the Artifacts tab, you will see here the doc build HTML directories, in which you've got the full Nilearn documentation that is generated. So if you click on it, you have a version of the Nilearn documentation, but here it's on the CircleCI server. And so you can check how your contribution in the documentation renders. Beware the cost of documentation generation. I don't know how I haven't checked how much it is recently, but some time ago, generated all the documentation for Nilearn would take 2.5 hours, which is a lot. It was very heavy. So we try to limit the amount of computation for documentation generation, which means that the examples should be kept simple. We try to avoid downloading lots of data sets because there's a risk that the servers that provide the data are not working well. And so we have a failure of documentation generation due to the data download. So we try to reuse the same data for all the documentation. And of course, the multiplication of examples can make the project messy. So let me finish this presentation with a small example, a cool example that was actually proposed last week. It's a surface searchlight example, so it's relates a bit to the work of Julia presented previously, which started contributions on surfaces in the library. Here, the question was about home. People like to do this so-called multivariate pattern analysis things, where they have this searchlight method, which is which takes a small patch of the image and creates a classifier and look at the prediction accuracy for features in a given region of the brain. So we've been able to do that in the volume for a long time, but people want to do that on the cortical surface. And the question is, how to design a good object that does that, for instance, okay? And what people have done, so this was proposed last week, is just to provide an example. Instead of starting a long development, we could just try and do it very plainly in a short example. So it's only 85 lines of code, which is reasonable. And actually, all these lines are just, as you can see here, the new examples that could be part of the library. And it's very interesting because it illustrates what the code should do. And when you look at it, actually, it's surprisingly simple. So to do a searchlight analysis on the cortical surface, you need to identify for each vertex its neighboring vertices. So a very simple idea would be to take that vertex on the inflated mesh and look at its neighbors on the inflated mesh, which reflects the correct spatial neighboring relationships, as discussed previously by Julia. And so actually, with just a few in 3 lines of code, you can call this A structure. Maybe A is not a good name, but okay, let's keep that for the moment. A is just a representation of all the vertices neighbors on this mesh. And then given that, given a data set, of course, and given a classifier and a cross-validation scheme, which are defined here, estimator and CV for cross-validation, you can give all that to the existing searchlight object. So X, Y, estimator, the A structure, the cross-validation object. And with this, you get a vector of scores, and you just need to plot this vector of scores on the mesh as a texture, as we said previously, by contrasting it to the chance level. And this is what you get. And so what I really like with this is that this example, maybe it's a bit too low level at the moment, but it gives us an idea of how the API should be, for instance, to define a very simple and very light surface searchlight procedure. Okay, I think it will be time to conclude now. So conclusion, documentation is essential. We cannot let a feature enter the library without a good documentation. And our suggestion today is to start from documentation because it leads you to better design and better communication with other contributors. Narrative documentation is essential for the big picture. So at the end, we think that people could learn neuroimaging concepts by reading the Nilearn documentation. And if we can succeed in that, then we've done the right job. And the writing overhead for documentation generation is small here, thanks to Sphinx. So with this, I would like to thank Nilearn core devs for organization of these days and all the discussions. Thanks to all Nilearn contributors. And thank you for your attention. May I just conclude by advertising a developer position that we are opening now, so to develop Nilearn further, especially with visualization tools, more support for bids, which I think that we are discussing, that we'll be discussing today and tomorrow for sure, and well, some improvement that we want to bring to the library. So you can see more about this job offers online. Thank you. So I'm happy to answer questions if there are any. Can I access questions? So I see 2 questions. Add-on on Nilearn, teams writing their own code and feature built on Nilearn with other dependencies. So yeah, so the question, not everything can go into Nilearn, so we need to find a way to have some libraries living with Nilearn in kind of ecosystem way, and not necessarily integrated into Nilearn. I would say that when we add things to Nilearn, there's a commitment to maintain this in the long term, and it has to be maintained by the community. So, for instance, even our own lab, we cannot, and we don't want to make all our scientific contributions as tools to Nilearn, because sometimes not everything is mature enough to be used by people. It's hard to maintain, hard to understand, and the benefits sometimes is not strong enough to outweigh the cost for the library. So not certainly not everything can go into Nilearn. I think that what I would promote is to share code like on GitHub or on GitLab or on projects that are openly accessible. And when we see that something is popular, so it's widely used by the community and then requested by people, then and it's compatible with Nilearn, does not add a big dependency, then we should consider adding it. Otherwise, I think we try to maintain the Nilearn as backward compatible as possible to make it a reliable dependency. So don't hesitate to depend on Nilearn because we won't be changing it too heavily.
There's another question, Bertrand. If you can hear me, the link between teaching material and documentations.
Here, I haven't talked much about teaching material. I'm not sure what this question refers to, but maybe you mean the narrative, maybe what I call the narrative documentation and the API documentation, or
so maybe you should explain the difference between what we call narrative documentation and API documentation. It may not be clear to everyone.
So in Nilearn, you've got, if you go to the web page that contains Nilearn documentation, there is a so-called user guide section, and user guide is what I call during the presentation the narrative documentation. So this one is really organized as an explanations of what are the tasks in brain imaging, what are the tasks that are addressed by Nilearn, and how can we can address them. So it introduces little by little, like almost as a course, the concepts that are implemented in Nilearn. And I think at the end, this is maybe the right way to discover the library, at least when you're a beginner. But I think it's for most people, it should be the right way to discover the library, and it should be pleasant. It should be pleasant because it teaches concepts in a plain terms, and it makes everything clear and accessible. So to me, this is the core part. If we succeed in that, then we will be able to share our contributions with the community. API documentation is a different thing. It's just, there is another, I think it's a reference tab, I think, in the documentation, where you can click on the functions and discover for each functions what are the arguments, what it returns, and essentially how to use it. But it's more technical, and it's more once you you have identified this function as something useful for you, you wonder how to use it, then this documentation becomes useful. Does that make sense?
So there was a question. But I'm not sure you answered the point on teaching, the link between teaching material and documentation.
I don't know, Gail, you have a suggestion, maybe?
Yeah, I can give my point of view. Ideally, we would like to avoid repeating. So we would like to make the material that we have as close as possible to teaching material. However, this is hard for many reasons. One of them is that the best teaching adapts to the audience. So ideally, there should be one material per audience. So the way we work, I think, is that we're more and more building what we call tutorial examples. There are a few of them, and they're very important to us, and they probably require more work, of course. And those tutorial examples, they need to be of a limited length because everybody has a limited amount of time available. But ideally, they should be the basis for an introduction to a specific feature. And then there should be maybe another example that's more advanced, and ideally, teaching should be able to basically take those examples and combine them and build a class. This is the ideal world. I'm not sure we're there, but this is where we want to be. There was a question with about the overlap between Nilearn and NiPipe and NiPy. Do you want to answer that one, Bertrand?
Yes. So Nilearn, NiPipe and NiPy. Sorry. Yeah. So Nilearn has been designed. So as Gael said after Julia's talk, historically everything originated with NiPy, which has built a community of Python developers and Python tools for neuroimaging. The NiPy project currently is no longer actively maintained, and so I think there's not much effort put on it. So I think it's not. I would not advise to rely on it as it is now. And NiPipe and so Nilearn are two important projects. So Nilearn addresses functional connectivity analysis, machine learning analysis, statistical analysis, modeling for fMRI, group analysis, and these kind of questions. And NiPipe is quite different. It's a way to organize your pipeline based on building blocks, which can be from different software environments. So you can, when you want to process data, you may want to reuse blocks from FSL, SPM, or different packages of free software. And NiPipe provides a way to organize these building blocks in a pipeline. So it's a different spirit. It's more a time of chaining complex treatments in a unified way. And it's actively maintained by the community. So Nilearn is more, once you have your data pre-processed, okay, now you want to do your statistical analysis, you want to do some analysis task on it, and for some of these analysis tasks, and Nilearn provides solution.
And there's a last question about the future of NiStats. It comes from Roberto asking, will it focus on implementation of univariate analysis, or has it more goal? I think we're losing Bertrand. He has a pretty bad connection at his place. So maybe I can comment. The goal of NiStat, well, the situation is that we want to decommission NiStat and merge NiStat into Nilearn. So basically, the idea is that in the long run, there will be no longer NiStats, and we will have Nilearn.statistics, Nilearn.something. It's been merged in. It's in the not released version, in development version of Nilearn. I encourage everybody to use it. We think it will make the ecosystem stronger, because right now you had to install and keep up to date 2 packages, and you will basically have only one to install and keep up to date. I think, in the interest of time, I think we should move on. And